Okay, so this is the next one in the series about the force-time momentum relationship. Okay, so we've got a giant bucket of water. You'll see why I'm saying this. A giant bucket of water with a big box sitting on top of it is moving along a frictionless surface at an initial velocity of 10 meters per second to the right. Bit of a bizarre example, but I'll show you in a second. It then experiences a force applied to the left of 50 newtons. Okay. How long will it take the 150 kg combined mass to come to rest? What I want to do is check our answer by using the simulation. Now I'll get you guys to check the times. I'm not going to check the time, but we'll see how it goes from there. So what I will do is, first of all, we know, it doesn't say it here, but we do know down here that the mass, the total mass, is 150 kgs. We know that the initial velocity u is 10 meters per second to the right. So again, I'll keep that positive because it's going to the right. Velocity, the final velocity, I want it to come to rest, just like the car crash situation earlier. So that final velocity has got to be 0. We know the size of the force. All these guys are vectors, of course. The force applied that's going to be causing this change in momentum is going to be 50 newtons. But that force has to be pointing to the left. So that makes that force a negative 50 newtons. Okay? Otherwise, your problem won't work out. Okay, what I'll try to do is I'll try to solve it mathematically first, and then we'll try it out. Okay, so what we're trying to do is find the time that it's going to take. So we're looking for the change in time, or the time through which that force is exerted. Okay, so we know that our force-time relationship says, let me just move my face. And the force-time relationship says that we've got force times the change in time is going to be equal to the change in momentum for the block, or the bucket with the big block sitting on top of it. And of course, I'm going to go straight for mv final minus mass times the initial velocity equal to the force in the change in time times the change in time. So the change in time is what I want to solve for here. So it's going to be the mass times the final velocity minus the mass times the initial velocity u divided by the magnitude of the force. Okay. So my time should be the mass. We know that the mass, well, I've got 100 kgs down here. I've got 50 kgs on top. So that's 150 kgs. My final velocity is 0 minus the mass again, 150 kgs, times the initial velocity, which is 10 meters per second, to the right, because that's going to the right. We take that one to be positive. But of course, I have a negative now in front of it, okay? And now you'll see why that negative force now becomes more important. When I divide by negative 50 newtons, a negative times negative will cancel. I'll wind up with a positive time. And of course, you should always wind up with a positive time in these situations. So this quantity here on the left goes to 0 because it's multiplying by 0. Then I've got 150 times 10, which is 1,500. That's my change in momentum, kg meters per second, divided by 50 newtons on the bottom. So what we can do then is, and of course that's negative. That's negative on top. Zeros cancel, and 5 into 1 to 150 will go 3 times. Well, 5 into 15 goes 3 times. The negatives cancel, and that leaves me with a time of 30 seconds. Now I'm going to try this and see if I can get it about right. Okay, pause the video. Okay, so I've set my timer here to 35 seconds just to be on the safe side to make sure that I'm able to apply the force for the whole time. And I'm just going to click go. So according to my calculation, it should be 30 seconds, but let's try it. I'm going to hit the timer, and then I'm going to apply that force. So 3, 2, 1, starting the timer. Now applying the force. Okay. So velocity is dropping. Hopefully you can see that the speed is dropping. Just please. Yeah. It's looking good. It's looking good so far. There you go. So I think we can say that that was a victory for physics. Okay, so the physics works. It did. It happened to work out to be 30 seconds. So I'd like you guys to try that one yourselves and post your work